Hello, geometry students. Mr. Zacek back and better than ever. We are moving in, and our unit is on transformations. And we're going to introduce a new transformation today called a dilation. And a dilation is a transformation that maps a figure onto a similar figure with respect to a center of dilation and a scale factor. So those are the two components of a dilation. We're going to have one is a center of dilation and two is a scale factor. So for the notation that we have here, you see that we're using the capital letter D. The first piece here, this O, represents the center of dilation, K represents the scale factor, and obviously P is the pre-image, and P prime then would be the image or the result of that dilation. So if you look at this piece that we have here, for this dilation, OP prime, so this is a distance, equals the scale factor, that's K, times the original distance. Original. All right, so let's look here what's happening. We've got our center of dilation here, point O, and we've got point P. What happens is that scale factor, in this case, it's taking it further away from O. So a good example of dilations that we can think of is when we use pinch zoom on a touchscreen device. So what are we going to do? We're going to enlarge or we're going to shrink an image. So we're doing either an enlargement or we're going to do some kind of shrink. And that is a dilation. We're creating a similar figure, which means that the size doesn't change. So in this specific example here, the second one, for a dilation of center O, the scale factor is 2. And so what do we notice? That from O to P prime here is twice the length as O to P. So we doubled the initial length. One of the ways that we'll be asked to do this, and we can do it, is if you have a compass and you want to do a dilation with a scale factor of 2, you take your compass here and you just move it up, and now you have doubled the length. And obviously, because those points are so very large, that is a little bit off in what we have going on there. All right, so dilations preserve angle measurement, but they do not preserve distance, and the distance changes by the scale factor. So we have a few things here to tell what's going to happen. If the scale factor is bigger than 1, the dilation is an enlargement. So this is the absolute value of K. If the absolute value of K is less than 1, the dilation is a reduction. So you want to think with here, we're probably looking at some kind of fraction as a scale factor. And if K equals 1, then the size does not change. So the scale factor of K of a dilation is the ratio of the length of the image to the corresponding length of the pre-image. So let's look at what that means. All right, so a dilation is not a rigid motion or an isometry, and that obviously is key. A dilation is not a rigid motion or an isometry. All right, so as we look at this, this is our pre-image, and therefore this is our image. So what's happening to triangle PQR? Obviously, it's getting bigger. It's further away from the center of dilation. So here we have point C. That is the center of dilation. When you pinch zoom on your phone, what it does is it sets a center of dilation and then enlarges it from that point. It takes all those little pixelated values and moves them in that distance. So K, which K over here again is our scale factor, how can we figure out what it is? Well, this C R prime, let's just really dig into what that is, okay? It's the center of dilation to the image. So from C to R prime, this distance here, divided by the center to the pre-image, the starting point, right? Which would be this distance right here. And so obviously from C to R prime is bigger than from C to R, so therefore this dilation would be larger than 1, and which is an enlargement, which the picture shows that this obviously is getting larger. Okay, so here's an example that we have, all right, of an enlargement. We have a center of A, and so the center is, let's get my pen here, center is A. What's happening now? Well, notice that A prime doesn't actually move because that's the center of dilation, but what's happening to C and C prime? The scale factor is 2, so all of those distances are doubling. So somebody might say, well, why doesn't A move? Well, what happens when you multiply 0 times 2? It's still 0, so therefore if the point is the same as the center of dilation, it doesn't move at all, okay? Now here's an example where we have this reduction in the center is C, and now if you look here, what's happening? I'm just going to go ahead and just look at G. So this is the pre-image, and G prime is the image. Now what do you notice? Well, G prime is closer to the center of dilation, therefore that's a reduction, and what do we see? The scale factor is 1/4. Okay, now when we look at this on the coordinate plane, predominantly we're going to do ones that are centered at the origin. So if it is centered at the origin, it's very simple. All you're going to do is multiply both x and y. And we'll do some examples with this. If it is not centered at the origin, then we have a little more work to do, and then we will do this particular formula here. And I'll show you some ways that we can do that that kind of make more sense graphically. That's a long formula to remember. So I'll show you some ways that we can do that graphically when we get there. All right. So next note here is notice the dilation takes a line not passing through the center of dilation to a parallel line and a line passing through the center unchanged. Okay, so if the line is like what we're saying here is like B prime, C prime, that's still going to be parallel. But if the line passes through, it's going to stay on the same line. So if we go from B prime to B, that just stays on the same line. Okay, now we've done a lot of kind of a lot of technical stuff here as we've gotten started, notation and digging in. That's a really good thing. Sometimes you know, we feel that struggle a little bit, but it's very helpful for us to be able to look at technical text and to be able to derive these solutions and thoughts from them. So a dilation is a transformation that results in an image that is similar to the original figure. The amount a figure is enlarged or reduced by a dilation is called the scale factor. Again, the scale factor, we use the letter K to represent that. A dilation enlarges or reduces a figure with respect to a point called the center of dilation. Which may be located by drawing lines that connect points to the original figure to corresponding points on the image. If a line passes through the center of dilation, its image also passes through the center of dilation. If a line does not pass through the center of dilation, its image is parallel to the original line. Okay, so which of the following properties are invariant under dilation? Invariant again means does not change. Distance, nope, the distance is going to change. Angle measure, yes, the angle measure will stay the same. Orientation, that'll stay the same. Perimeter, no. Area, no. Collinearity, yes, they'll still be the same lines. Parallelism, yes. Perpendicularity, yes. Okay, if something's perpendicular in one image, it will be perpendicular in the other image. Okay, so in this case is XTR equals, is this dilation centered there at N? Is this a enlargement or reduction? Okay, so this is the pre and this is the image. Let's go ahead and look. So we've got R and then we've got R prime. Here's what I want you to notice. You see how the pre-image and then the image, so the image is further away from the center of dilation, so therefore this is an enlargement. All right, the triangle's getting bigger. What is the scale factor? Okay, well, we don't have it for R, but we do on this line here with T. So remember that the scale factor is going to be, in this case they're calling it N, it's going to be X T prime, the image, over the length from the center to the pre-image. So that would be, the full length of this one would be 12 divided by 4, and so the scale factor would be 3. All right, and so here's another way of thinking about it. If T is 4 units away from the center of dilation, if we multiply 4 times 3, T prime will now be 12 units away from the center of dilation. Okay, so in 4, is this an enlargement or a reduction? Well, what I want you to notice, let's find our center of dilation. Here's the center of dilation. What's happening, we're going from J to J prime. The pre-image is further away than the image, so this is a reduction. And what is the scale factor? So I'm going to look at O J prime over O J. All right, remember, image over pre-image. If you use this vertical line, we don't have to do the distance formula, we can just count. All right, so I should have, that's not a prime down there. Okay, so image, so from O to J prime, though, that's 1 away, and from O to J is 2 away, so that's 1/2. So the scale factor for that is 1/2. All right, now triangle PZG has these vertices, graph PZG, and its image. Okay, so sometimes we gotta, let me write these out. -2, 1, and G is 0, -2. Let's graph it, and then I'll talk about some of these specifics. So here's P, Z is -2, 1. Whoops, did I graph P wrong? I did. P should be 2, -1. Okay, and then G is 0, -2. Okay, so there's our triangle. All right, now what you'll notice is that in this dilation here, they don't give us a center. When you don't get a center of a dilation, you're going to assume the center of dilation is the origin. Okay, assume the center of dilation is the origin. And the nice thing about the origin is all we have to do to find this image is to multiply the x value and the y value by 2. So this would be 4, -2, -4, 2, and 0, -4. So P prime would be 4, -2. P prime. Z prime would be 1, 2, 3, 4, +2. That'd be Z prime. And 0, -4 would be G prime. So there we have that, the new figure there. So what do you notice about the slopes of the corresponding sides? Well, we should notice here then, look at the steepness. So if you like G and P and then G prime, P prime, we're going up 1 over 2, up 1 over 2, okay, and they're equal, or they're the same. So what does this tell you about corresponding sides? Well, if their slopes are the same, then corresponding sides are parallel. Parallel because they have the same slope. Or sometimes they're exactly the same line. So like if you look at the center and P and then P prime, that's the same line, versus like Z prime, G prime, and ZG, those are parallel to each other. Okay? All right, now another one along the same lines, but this time we have a little bit of a different scale factor. Now here the scale factor is 1/2, so PZG, and now we have a scale factor of 1/2. Again, we're assuming that this is centered at the origin because we're not given a different point. So P prime, Z prime, G prime. So all you're going to do is multiply by 1/2, which is going to make this 1, -1/2, -1, 1/2, and 0, -1. All right, so still thing here, we've got P, so P is 2, -1, Z is -2, 1, G is 0, -2. All right, so there's our initial triangle. And then basically what happens is everything just gets half of the distance closer to the origin. So 1, -1/2 is going to be here, and then -1, 1/2 would be here, and then would be here, and so that's just our triangle. So P prime, Z prime, G prime. What do you notice about the slopes of the corresponding sides? They're still equal, the same. And so what does this tell you about the corresponding sides under a dilation is that they are parallel. So they're still parallel. So corresponding sides are still going to be parallel. And notice again, the image is closer to the center of dilation. Okay, we got a few questions left. Number 8 is going to be really important, but let's do 7 first. The height of a document on your computer screen is 20.4 centimeters. when you change the zoom settings on your screen from 100% to 25%, the new image of your document is a dilation of the previous image. So what is the scale factor? So again, when you're thinking about the scale factor, which is K, K is always equal to the image divided by the pre-image. That's what you want to think here. So in this case, the image is 25, the pre-image, the original, is 100, which is 1/4. So if we move something from 100% zoom down to 25% zoom, that's 1/4. So if we take that 1/4 and we multiply it by our height here, we're going to get 5.1 centimeters would be the new height of that. So we could use that in relationship to the percentages here. Okay, now number 8. The line y equals 2x minus 4 is dilated by a scale factor of 3/2 and centered at the origin. Which equation represents the image of a line after the dilation? Okay, here's the things that we want to keep in mind. Two things to consider. Number 1 is that it will be parallel. Say it will be parallel. In other words, it will have the same slope. Okay, and number 2, the y-intercept will change by the scale factor. So let me diagram this out, because this is going to be a common question that you're going to see a lot of. All right, so my initial line is 1, 2, 3, 4. It has a y-intercept of -4 and a slope of 2, which means we're going to go up 2 and over 1, 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 or left down 2 into the left 1. Okay, and I'm going to draw that line. So this is the line y equals 2x minus 4. All right, now the scale factor here is 3/2, which is bigger than 1. That means that this one needs to move further away from the origin. It's got to get further away. I know that it's parallel, so I'm going to reject choices C and D because it needs to have the same slope, and the slope is 2. So how do I figure out this second part of it? Well, what is this point here? It's the point 0, -4. And so really what we're doing is we're taking the point 0, -4, and we're going to dilate it by a scale factor of 3/2. Well, what's 0 times 3/2 is 0, and -4 times 3/2 is -6. So in other words, what happens is we move this down, and it still is a parallel line to that initial line. But what's the y-intercept? The y-intercept of this line now is 0, -6. So that would be choice B. Okay. All right, and last one, similar to that. The equation of a line H is 2x plus y equals 1. Line M is the image of line H after a dilation of a scale factor of 4 with respect to the origin. What is the equation of line M? So here's what we do. 2x plus y equals 1. We subtract 2x. So y equals -2x plus 1. All right. Two things you have to consider. Same slope. Dilate the y-intercept by the scale factor. So dilate the y-intercept by the scale factor. So here's number 1, same slope, dilate it by the scale factor. So the y-intercept here is the point 0, 1. So we're going to dilate 0, 1 by a scale factor of 4, which is going to make it 0, 4. And we're going to have the same slope. So, so line M then is going to be y equals negative 2x plus 4. Alrighty, there we have dilations. There's a little bit of work we're going to do with constructions, but it's applying the same things. So again, really key topic, important one, little longer videos like we have this unit, but we got a lot to cover, and this is really critical stuff. So if you have any questions, please ask them, and I'll see you back here soon.